Okay, welcome to our next episode of our webinar series. Thank you all for coming. I appreciate it. We've got a pretty exciting one today. It's number 51 since episode number 51 since we started these in March, and we have been going strong every Tuesday and every Thursday since we started. Lots of great information. I have learned such a ton, and I know you have too. Got lots of good feedback from all the people. We'll talk about our next webinar when we get to the end, but I will share with you that the next webinar was based on about 4 or 5, 6 or 7 webinars ago. We took a vote for what you would like to have. We hit the top 2 of those, and the number 3 in voting is what we're going to do on Thursday. So I will share with that with you as well. Today we're going to talk about introducing the AiM Sports PDM, and the subtopic there is more than a power distribution module. I know this has been a device that a lot of you have been very excited about and waiting to learn more information about. We're going to go ahead and do that with you. We're going to talk a lot about some details certainly, and some questions from you, and we're going to throw a lot at you pretty quickly. And don't the reason that we record these and put those on YouTube is because we need to get as much into these hours as we can, and so if you miss something or you don't think you quite understood it, within an hour or so this will be up on YouTube with all the links and the documents that we talk about, and including the PDF itself. Robbie will probably link the presentation materials we're about to go through. You can download that if you'd like to right now and have that, or just there it is. If you want to, there's the presentation, all the slides in a PDF. We zip everything up, makes it easier to download. But so you can grab that if you want to do it. It's certainly it's there for you for later. All of these links that Robbie gives you will also be in the description box in the YouTube video when we get that up there in about an hour or so. Perfect. What we're going to talk about today is the AiM Sports PDM. We're going to talk about just the overview, right? What is it? What can it do for you? Why would you want to use it? And then get into some of the technical details of what can it do, things like that. So some of your specific questions may or may not be the right time to ask those right now. But if it's more general in nature, on kind of on the introducing topic, let's do it. So. We have a first-time co-host today. Fabrizio Rizzi is from Italy. He's the let me jump one slide up here. Click this. There we go. He's the hardware team manager from our AiM Italy, and got a couple pictures of him here that you can see. One of the things I enjoy most about a lot of the Italian folks that I've met and worked with is they, as you can see from the pictures here, they get out into the field, and the one on the top there, he's got his Mint 400 credentials for the Las Vegas Mint 400 off-road race that he visited and learned a few things about different things. The lower left down here is at the PRI show in Indianapolis. It looks like an IndyCar event on the next two with our AiM cohort Cameron standing there with him, as he was probably there working with Cameron on the Smarty Cams that are universal on the Indy cars. So what I really enjoy that him and Emiliano, many of you have met and talked to through these webinars as well, always out at the racetrack, getting practical experience. They're not sitting at their desk just taking a look at things and trying to figure out what's best. So I just enjoy that a lot about this company, and especially the Italians that are putting a lot of the stuff together. So I want to introduce Fabrizio. And have him start talking a little bit about himself, more than I can, obviously. So he's a hardware team manager. Currently has been doing that, has been working with AiM since 2014, and super smart guy, super brilliant when it comes to this electronic stuff. Started in 1999 as a firmware developer on microcontrollers, and then worked through, and also ended up working into the hardware development side on where those boards were mounted, which is pretty much what he's doing these days, right? So I'd like to turn it over a little bit to you, Fabrizio, and chat a little bit more. Give us a little bit more of a background on who you are and what got you here, and and maybe just a little bit of a lead into the PDM. And then I've got a couple of polls that I do want to run. They're a little bit different. They're more PDM specific polls that I'd like to get some information from the folks that are watching here today. And so give us a little bit of information, and then we'll start this thing with a poll before we get into the actual presentation.
Hi, Roger. Hi, everyone. As you said, I'm Fabrizio. I'm the hardware development manager of the AiM. I'm very, very happy to participate to these webinars, and I'm very, very enthusiastic to have this opportunity to speak about the PDM, because PDM, I think it will be a very, very big, important device in the IAM scenario. What can I say? You say the all of my career. I can add a couple of things. I started my career working in a small factory in Italy, in the broadcast field. Then I jump in the industrial and automotive sector. Main and important work that I did in the automotive sector will be with Marelli and Cobo, that are two big factories in Italy. And I collaborate with the team for the development of the Ferrari, Maserati, and Lamborghini dashboard, and some of the electrical parts they have inside a car in series production. I'm in AiM since 2014. We try to develop a new system every day, but in the same time we try to make the actual system more reliable and more user-friendly for our customer. This is our goal. What can I add?
Yeah, perfect. No,
probably I can give you a little summary of the story of the PDM, the development of the PDM in AiM, because it's for some circumstances is a little different from other products. We start the idea to develop the PDM with some AOM manufacturer. I can say Dallara, for example, Motomorini, that are a car maker in Italy and a motorcycle maker, and for Ariel in UK. For them, we try to put the idea to manage some of the feature on the car, typical lights, horn, and some little loads for the car, inside the logic of the dash. So we develop for them a dash that's called MXSL that manage also the logger data, the TFT, and something else. And we include in the dash the functionality of the power output. We work a lot to choose the right components, the right idea, and the right management of this kind of loads. And I think today we have the opportunity to move that little scenario to the high level system that is our PDM. This is why we say the PDM is more than a power distribution module, because as we can see during the webinar, we put inside this device many features that other vendors don't put inside a single device. And this is maybe the difficult thing that we have done.
Yeah, if it was easy, everybody would do it, right? So you've had to work very hard, and I know there's a lot of background, a lot of work's gone into this, and it's it'll be fun for everybody to get up to speed on some of the technology that's built into this. So I'm going to slide up one slide, but I'm going to start with the let's jump through a few slides. I just looked at the poll, and I think it'd be better to get a little bit of background information before we do the poll. So let's talk about, you start going through some of these slides, PDM versus your standard way we've built race cars for years, right? Relays and fuses and a normal wiring harness. Talk a little bit about the difference between them, the main advantages and additional features.
Yes, well, a common question that usually asked to us is why I have to change a more comfortable, more in the mind, user-friendly, really fuse box with a new PDM. What's a PDM? There are many advantages. First of all, for our point of view, is that you can do a harness and the connection more simple and cleaner. Why I say this? Because you have a box in which you put all the functionality, and you have only the wire that starts from that box to the loads. What does this mean? You have a big reduction on the weight because you have a lot of wire that don't move around your car. And you have a very, very easier way to check if you have a harness wiring malfunction. If you know more or less the system of the AiM, if you connect to the box, to the device with RS3, the ReStudio software, you can go online and in a while you can take a look for what is not going in the right way. For example, you have to check what is the activation, let me say, variable. So the switch that have to activate the output. And you can see if the activation input is on or off. And in the same way, you have to know that your load has to be activated or not. So in that case, with just one look, you say that if the problem is on the activation side or is in the load side. So it's very, very easy to check some malfunction. Also, during the development of the vehicle, you can change your strategies. You can move your outputs in some location without changing more or less anything, because you haven't to add a relay, you haven't to add a switch and something else. You simply change the configuration of the device, and in that case, you move the one function to another, or you can add or remove a function or input that can switch on or switch off, or more deeply, change the way that the load function just in a while, just with the configuration. So you don't touch anything on the car, but you simply change your configuration. This is also useful to analyze the power. So in some situation, you have also very, very simple in a look, the idea on what power is flowing from the battery or from the alternator to the loads. So you can check if all is okay, if you have a good dimension of wire and something else. You can analyze this data also in a post-processing, because you can save data as our other device and take a look after you can work. So you can also implement many strategies to optimize the power consumption, because in many cases you need more power during some situation and less during the other. So you can automatically switch off, for example, a lot of light on the roof on the vehicle if you need more power, so you can reactivate automatically when the condition change. There are also additional features, because you can monitor and record the current. You can do some strategies that can help you to have a predictive warning. What I mean about predictive. For example, we have a fan that absorbs more or less 10 amps. A stone goes onto the fan, and the fan starts having problem working. Probably we have a higher level of current, so we can check and give a user an alert that some is not going in the right way. You have also easy to change the activation of the rule during your development, and also during the running of the tracker or the road or something else, because you can implement many strategies. And this is not so easy to be done with array or fuse box, because you have to add some pieces, remove some others. If a fuse broke because you have, for example, a higher level of current that way, you have to stop the car, you have to change the fuse, and then you can restart. With the PDM, it's very, very easy, because you can set the trip level of the current. If the current goes higher, simply the supervisor of the outputs take a look to this. If you program in the correct way the output, the PDM can shortcut in a while the power, so the output will be is activating. And then you can set many retries to see if the current goes in the right way, or if otherwise you have a continuous having problem. So in this case, you can change in a while the level of the trip current, you can set the auto restart, and you can configure in very, very simple step what the output has to do in many situations. This is more or less the difference.
That's a very, very powerful list of things to do, and especially that last one, right? In motorsports, you can't just pull over and change a fuse, right? It certainly is nice if you can get around in an endurance race to get back as your fuel pump's starting to have too much draw and it starts to pop the the circuit breakers or whatever. So very, very powerful, very, very powerful things. Interesting. Okay. Let's talk about the next slide just a little bit, and now we're going to start to dive into some of the different options that you have, right? And some of the it's a little bit technical, but it's Fabrizio will give us an idea of not only how it works and what they're called, but then give us some examples as well on some of these slides. So that's kind of nice. So go ahead.
Yeah, it's just a way to say to the user which is the main difference on the output, because in many times we speak with some users that don't understand how is an high side, a low side, and something else. So we put some very, very easy slide for say what's the difference. More or less, or the most of the loads on the car as a common pole that is the GND. Typically is the chassis of the vehicle. So what you need to switch on the loads is to put a battery level 12 volts on the load. This kind of feature is called high side. High side because the high power is connected from the so-called high level pole, so the 12 volt battery. This is the typical way that you connect the load. For example, a fan, for example, a fuel pump, all the lights more or less has this kind of connection and something else. So when you think an activation, 90% you use an high side out.
Perfect.
Can I change the
next one? Let me try to get it. I clicked and there we go.
Okay. Otherwise, we have also the low side, which is the opposite. The load is connected permanently to the positive pole of the battery and needs to be shorted to ground to be activated. Some little example is some relay, very high power relay. The main switch, when is electrically controlled by something else, typically they requires a short to ground to be activated. This is the function of this kind of feature.
Okay.
The intelligent mix of the two possibility is the full bridge configuration. What can you do with a full bridge? Simply, you can connect, for example, a motor between two different half bridge output, and you can reverse the motor version, simply changing which is the side that is connected to the high voltage level of the battery and ground. So when you see the upper scheme, the left full bridge is activated in high side and the right on the low side. This means that the motor probably turn clockwise. Otherwise, if you change the polarity of the output, you have the inverse verse of the motor. All of these outputs naturally could be as a fixed activation. That's so-called typically high side or low side, and can also be used with the PWM. PWM stands for pulse width modulation. What does it mean? Very, very simple. You can connect directly to the battery and you have a fixed 12 volt. So, for example, in this case, a motor course at, I don't know, 200 RPM. If you reduce the voltage across the pole, you have a lower speed of revolution. So the PWM more or less do the same, reduce the energy that is given to the load. And in that case, you can reduce the speed, for example, of the motor. You can also dimming a lamp. You can dim, for example, a fuel pump, a water pump, and something else. And as we can see in the next slide in this webinar, this is very useful to give you a very, very versatile to use all the loads that you can do. Why? We say more than a PDM. Why it's more than a PDM? Because the PDM is typically a power module. So is used to activate some loads and nothing else. We put in the PDM a dash controller. So if you have a PDM, you can connect with a very simple and inexpensive device that is the remote display with a LVDS cable. This is a very, very small cable that can connect the display, and we have fundamentally a TFT information goes from the PDM to the dash, and we can also manage the device that are inside the dash, for example, the push button, for example, the light sensor, the LED for the shift light, for the alarm, and something else. So we realize a very, very small and easy connection to have a dash connected directly to the PDM.
Nice.
PDM can naturally manage many of the expansion that we have. One of them is the GPS module. So we can absolutely, as the other device, manage with the AiM database, many tracks around the world. We can manage directly the lap time and show the lap time on the display and record the lap time in the memory we have inside. Why we can store this? Because inside we have also a data logger. Data logger, as other instrument, we have 4 GB of memory, and we can recall and record all the data, all the expansion that are connected can be saved, and also all the data related to the power current, to power state, and to the activation is stored inside. This is very, very useful to can analyze what happened if you have a fail, or if you have to simply check that all is working as you think.
Perfect.
This is in a short list the main features of the PDM. So we have 14 fully configurable inputs, 500 Hertz each one. 8 of them are selecting in analog or digital function. 4 are digital input, and 2 of these is related to the speed input. So we can connect speed sensor and something else. We have 32 power outputs. 4 of them are rated to 20 amps. We call them high power. 12 are 15 amps mid power, 12 10 amps, and 4 are 35 amps. The last 4 has also the functionality to be a alpha bridge. All the power output is protected for over voltage, for the under voltage, over current, over temperature, and we can manage a continuous total current of 120 amps. Naturally, it depends on the heat of the installation of the PDM, because as we can see later, a good installation gives you the big opportunity to through all the current you need. We have also 1 link bus. We have a 3 CAN connection. 1 is reserved to the AiM device, and 2 are completely configurable for ECU and something else. We have put inside also inertial platform that is very, very useful. For example, to start some strategies that I mean, is high-level strategies, but one of our user is already doing it. For example, when the car is 45-degree inclinated, he starts also the second pump, the fuel pump, to maintain the fuel pressure at a very high level when the fuel tank is not completely full. So, for example, this is a use that could be done automatically with the inertial platform. We have 4 gigabytes external module that we can connect more or less all of our device. We have also 2 camera input, 2 analog camera input that is very useful. For example, to see what's happening around you. Waterproof, dimension and body, more or less like the other device.
Got a couple of questions that have come in that I'd like to maybe slide in here. What is the LIN bus? You mentioned that earlier, LIN, bus. What is the distinction and difference between that and some of the other types?
Well, LIN bus is more or less like a K-line. It's a high level of a K-line. You can connect only one wire, you have a master, and you can typically connect windscreen wipers to adjust the speed, something else. You can connect the windows of the electric windows of the car, the rear heat for the glass, and something else. Is a cheap way to communicate with a very, very low device on the car. This is more or less a standard that use maybe on OEM cars, that not on truck cars, let me say.
Okay. And Mark asks, can analog inputs, as part of the PDM, can analog inputs be used to record or act upon either a trigger from the ECU or a traditional switch? Can we use all of the different things? I think the answer is yes. So just like a standard data logger, but we can also use other information coming from the PDM as well to trigger things, build status channels, things like that.
Yeah.
Okay. And and Tice says, what's the difference between an accelerometer and a magnetometer?
Accelerometer measure the G-force that you are going into. For example, if we are completely leveled and completely in a steady state, we more or less measure 0G on the x-axis, that is the right one, 0G on the y-axis, that is the straight way, and the 1G versus the floor, that is the force of the earth. Magnetometer has the functionality to measure the field of the magnetic field of the earth. So with some mathematical channel and something else, and a lot of experience, you can, for example, know which is the compass. If you are, for example, on a completely stay in a position, the GPS give you only a course over ground, so it's not the correct information about your position, it's the information about your movement. With the magnetometer, you can say which is your direction respect to the real north of the Earth.
Yeah, basically, the easy description is it's like a compass, but it also has some more depth to it as well.
Yeah, you are right.
And then all the promo pictures show this with a different new looking dash. I suppose he means the 10-inch dash. We'll have some pictures of that here in a minute. Can we use existing dashes, MXSs, MXPs, the existing stuff, maybe some Stratas or normal dashes with the PDM?
Yeah, you can connect the existing dash via CAN bus, because you can stream on the CAN output of the PDM all information that you can see on the TFT. But the big impact of the new dash is that the cost is very, very low respect to a complete dash. And the connection is very, very easy, because with one wire you put the power, the information, and the back channel to manage the start button, to manage the luminosity and something else. So with only one device, you have all in your hand.
Yeah, the PDM has all the smarts, and where the dash loggers, the current dash loggers, have a lot of that in there, so that it ends up being a much more expensive solution. So that's why the 6-inch and the 10-inch dashes will be available. So perfect. Let's jump to the next slide, and let's talk a little bit. And after this slide, we'll do a quick poll. Give us a little bit about the specifications.
Yes, what is writing is the operating temperature, so 15 Fahrenheit to 185, This is measured by internally temperature sensor because this is the temperature, the working temperature of the internal system of the PDM. Max current is 120 continuous. This value is related to the outside output. Why? Because you have, we see after, a big connector that is a surlock that give the PDM the 12 of the battery. So this is the positive power. When you use the low side output, the current is not sourced by the PDM, but is synced by the PDM. So you need also a route to QandA that can move more or less the same current. And in this case, we have 4 QandA pins. Every pin is rated to 70 amps. So more or less, if you use all the capability of this, you can draw the low side 17 per 4 current. As I said, it's very, very important that PDM has to be installed in a not heat situation and maybe in an air ventilated side. You can find some instruction in the PDM. Power supply from 6 to 16 volt for the functionality, but as we can see later, some feature will be stopped after 8 volt to protect the loads and the power out of the PDM.
Okay. Now that we've gone over a little bit of the basics behind the PDM, I want to start a poll that gives you maybe a little look into the future of giving us some direction. Now that you have an idea of how this might work, I'm going to launch a poll here, and the question is when you consider an ideal PDM installation, you the user, what would be your suggested configuration? And basically and you only get one choice here. I did not make this a multiple choice, but the one central device that manages all outputs and inputs, that's basically what we've been talking about here so far, the PDM32, right? Or would it be important to you to have more devices distributed in the vehicle? In other words, connected with a CAN and a single power wire, and then have the distribution happen from a central box, or one in the front, one in the middle, one in the back, kind of a thing? Or would you like separate devices for the inputs, the analogs, and the input side of it, and then the output side, right? So give me an idea. We're going to let that run for just a minute while we take a couple of question and answers, because I know you have to kind of think that one through for a minute. And we're just looking for your ideas of what kind of works for you and maybe in the future. Something that's talked about in the question, Mark mentioned a couple of things that are tied together. What about the Formula Car wheel showed in the Radical SR3XX? Is this the new Formula Car V4 wheel? Since you're the hardware guy, you probably do have an answer on this. Is that out there? Is that what they're seeing on the new Radical?
Yeah, sorry, but I have lost this connection.
Uh-oh, can you hear me okay?
Yeah, now yeah.
Let me make sure I didn't.
I understood until RS3 configuration.
Yeah, the new Formula Car wheel. Do you is on the Radicals? Is that is that out there? Is that out there, and will it work with the PDM?
Yeah. Well, we put our PDM on that car, and they use more or less all the outputs. We have maybe 2 or 3 outputs that is a spare, and they are very, very happy for the decision and for the reliable and the way in which they has developed the car around the PDM.
Okay, perfect. We do not have a picture that I know of the new steering wheel, so don't have anything to add to that yet. So let me end that poll. We've kind of cleared the questions. Let's end that poll and let everybody take a look at it real quickly. The one central device which is what we have designed as of right now, seems to be very, very popular. If there is a different choice, it might be, and it's about 18%, 80% for the first one, and then the other one that has a little bit of interest, about 18%, is more devices distributed in the vehicle, right? The expansion thought process, one in the front, one in the middle, one in the rear, something like that, or maybe just one in the front and one in the back. Todd had a kind of a funny note in the chat box. He has a Miata, so it's 1 foot front to back, he said. So wasn't too much of a concern to him. So I appreciate you giving us a little bit of feedback, and something that we can just continue to think about a little bit. So I will stop sharing those results and get those out of your way. And we will go up to the next slide, kind of continuing on. Some of this we've chatted about already a little bit, but maybe you can go through a little bit of some of these, especially when we get down towards the bottom of this page. It's some interesting things there.
Yeah, more or less we have the same conditioning for the signal as other devices. So we have a plus 5 volt analog reference with 1% precision up to 500 milliamps that is used typically for reference for external sensor. We have also a 12 volt output, also regulated 350 milliamps, more or less for the same reason. We have to power external sensor that need 12 volt. Both are protected internally. I want to say that all this because it's very, very important. All inputs are protected from high voltage burst and surge because many way we found that user connect very high voltage device to the system, and so we have to protect all our inputs in this condition. Other important things to do is this outputs H1 to H4, that is the 20 amps rated output, have internal freewheeling diode to manage the high voltage spikes that is produced by the inductive load. This is very, very important because when you connect a very high inductive load, for example, a big relay or, for example, the electro valve, something else, they generate a very, very high voltage spike that can damage the system. So in the next slide, I try to explain this condition. H1 has also a series diode that is useful. Connection to the battery. As I said before, a connection is made by a Surlock connector that is a very, very interesting connector. It is IP67 rated, can manage up to 120 amps, can manage wire from 16 square millimeter to 25. And the big advantages of this choice is that it's very, very easy and simple to connect it to disconnect. It realizes a very, very solid connection. And with this feature, you don't need anything to connect the pole battery to the PDM. It is a very, very, it's not, let me say, dangerous way to do. But if you choose, for example, a don't right connection to this, you can have a big failure for the PDM.
Let's go down one. There we go. And how do we connect all the harnesses to the PDM?
Yeah, all the harness for the PDM has a connection of two 35-pin M seals. These connectors are very, very used in the automotive sector, and they are sealed, rugged, designed for high temperature, rated P67 and something else. As I said before, every pin can manage 70 amps of continuous current.
And there's a lot of pins. So here's that cable we talked about a little bit earlier, and you got an additional question on it. So here's a little bit more information on how we connect the remote display.
Yeah, this is the custom cable. It's made by Rosenberger connector. That is a high-level standard in the automotive for the serial link communication. As you can see, we have 1.5 gigahertz frequency in the communication. So we can make a connection that is very, very faster and is very, very reliable because this kind of cable is very, very immune to the noise level and for all that more or less is around the car. So this is very, very simple connection, but it's very, very important, the choice of this kind of connector.
Perfect. Camera inputs.
Camera inputs, we have two external inputs available. You can activate the camera by configuring with the race to free your choice. Typically is the rear gear, but you can switch on the camera, for example, with a push button or any situation. It's available both on a 6-inch and 10-inch display.
And you can use that as a backup camera, if needed, or as an electronic rear view mirror, right? And be able to look at it that way if you wish. So pretty powerful tool there.
Remote keypads, this is very, very important because to manage the outputs, you need the user to have the possibility to switch with some inputs. We have a remote I/O input expander. That is the system on the left. It's called Rio. And we can manage also other vendor keypads on a canvas. In the next release of the ReStudio, maybe it's available during the next hours. We can manage directly the configuration of, for example, in this case, Blink Marine manufacturer. But you can do your own protocol to manage every kind of keyboard on the canvas.
Perfect. So, somebody was asking, is the Rio released yet? Is that something that they can get? I do not know. Is the Rio released?
Yeah. Rio is released. We keep them a little in the shadow because we want to show to the world the complete kit that is made by PDM, the Rio, and display and something else. But in the next day, also the documentation of this module will be available, and I hope will be more user friendly.
Okay. And I was going to save Jeff's question till later, but since we're in question mode, could you comment on when the EPM will be available? I do not understand what the EPM is. So do you, Fabrizio?
I don't know. EPM, I don't know.
Give us a little bit more of a hint there, Jeff, because I do not know. Is AiM going to sell its own keypads as expansion power module? Is what Robinson is saying. Expansion power module.
Ah, okay, yeah. We are working also on it. That is a little PDM that can be added as auxiliary output on the master one. Okay. That is called expanded power module. It's not ready, but I think in the next week we will be able to show also these features.
And is AiM going to sell its own keypads? I know we're talking about third-party stuff, but are we going to be putting together our own keypads as well?
Yeah, during the next day, I think the ReStudio can show the powerful of the connection with the keypads in CAN. In the picture is show the Blink Marine, but I mean, user can connect every PDM if he wants to do ourselves the protocol. It's very, very useful to activate and deactivate the outputs and to manage a user-friendly inputs on the vehicle.
Okay, and the next question there was that at what connection speed will it be supported? CAN open at 1 megabit?
CAN is fully configurable. Actually, the Blink Marine that we use is working at 125 kilobits. But our CAN can be configured up to 1 megabit. It's a CAN 2.0b system, so you can set the speed you want.
Okay. And there's a lot of information here. Maybe we leave some of it to be read by them, but give us an overview of some of these outputs, and I think we've got a second screen as well.
Yeah, I also explained the different of the outputs. We have 4 different kind of outputs. Typically, they are different by the continuous current and the inrush current. The continuous current is obviously the current that you can draw in a long time. Inrush current is the current that the load typically requests in the start of activation, typically 100 milliseconds or something else. As you can see, we have different kind of outputs to give the user the possibility to manage different kind of loads. L and M are up to now not protected by freewheeling diode. I mean, they are protected up to 50 volts generated as a spike. All the other as internal freewheeling diode that protect with 400, 500 volts without any problem.
Okay. And then the half bridge outputs down below. That's you chatted a little bit about that before. You know, when you start to put those together, we had that one drawing.
Yeah, yes. Alpha bridge, respect to the high side, has the advantage to be used in two different ways: high side mode and low side mode. So you can manage two different type of loads, close to battery or close to grounds. Combining a pair of them, you can realize the full bridge configuration to reverse and manage the motor direction.
Typically, in your you talk about here in the last bullet point, there is typical application will be managing windshield wiper motor type of a thing.
Yeah,
linkers,
sure.
and something like that. Okay. And a little bit more on outputs.
Yeah, this is the feature of the outputs. Our outputs are checked, so we manage and can keep track of the overcurrent, over temperature, short circuit, open load in on step for every output, and in some cases L and M type as also the open load checking of states. This is very useful, for example, when you are going to disconnect a load to do some operation, and then you don't remember to reconnect the load. The PDM can give you an alert that that load is not connected before you have to switch it on. That is very, very important. We have a little current that flow for these features. So if you switch on the LM out this kind of a feature, you can see a little current on the output that can switch on a small LED. So typically, if you have, for example, a DRL that need a small amount of current, you have to disable this feature to have the LED that is very, very, very light on. L, M, and H outputs have also a pulse width modulation that is fixed at 100 Hz. B-type, half bridge type, has the possibility to change also the frequency of the PWM. Typically, PWM works changing the duty cycle. You can dimming a lamp, for example, giving the 10%, 20%, and something else. Some application requires to change also the frequency. B-type can manage from 1 Hz to 10 kHz the frequency the user wants. For example, for fuel pumps or other critical loads that require this. Another important thing, the last one, that all these integrated circuits that manage the power outputs are AC Q100 qualified. That is the standard for the automotive safety qualified circuit.
Okay. Let's see, and this is just a screen capture of how Race Studio 3. Those of you that have Race Studio 3 beta, you may have played around and looked at a little bit of this, but this is just some of the power of the outputs. I think this is going to ask a question that I just seen a minute ago, as far as if something was a little bit too much power or too much draw, will it delay it, or will it try, will circuit breaker or fuse pop? This is where you set all that up.
Yeah, this is. I think we will go deeper in this screenshot in the next webinar. What can I say is these are more or less the configuration you can set for an output. So the max level of current, that is the trip level, the overcurrent latch-off time, the time in which the PDM decided to disable the output if the current goes higher than the trip point. The number of retries, you can set the PDM to retry 1, 2, 3, 10 times when the current goes over. The delay from one retry to another, the minimum current. This is useful for enable the open load check in on configuration. For example, a fuel pump draw typically 10 amps. I can set here 1 amps because if I want to switch on the fuel pump and the current is less than 1 amps, I can say that the fuel pump is not working correctly. The checkbox for the open load in off state is related to the L and M output that have also this feature. We can set also a soft start, a soft stop, that is a way to reduce the inrush current, because we set the time in which the output goes from 10 to 100% of the duty cycle to reduce, for example, the inrush current of a fan, of a fuel pump, and something else.
Perfect. Let's here's a little bit more of a technical drawing on how this kind of works, right?
Yeah.
How the power output is supervised in this particular terminology.
This is a little scheme to try to understand which is the work that the supervisor has to do. More or less, if we start from the left, we have zero current drawing in the time. Then the user switch on the loads. We have a high inrush current that can goes over the user max value without any problem within the time that is T1. T1 is the time in which the supervisor don't check the overcurrent. This is the inrush current capability. Then the current is stabilized in this level, for example, 10 amps. At one certain time, we have an overcurrent overcurrent event that dures up to T1. In this case, the supervisor check the time, see that overcurrent goes over what the user has set, disable the output, wait for the T2, that is the retry time, and then if set the number of retries that is more than 0, the supervisor reactivate the output and so on. This is more or less what the supervisor has to do, and the parameter that the user can configure to manage every situation.
Very cool. Inputs, pretty much typical of AiM data loggers, right? More or less.
More or less the same. We had only an additional feature that is the pull up of 2 kilo ohms, 0.1%. That is an internal reference, so the user can connect externally directly a potentiometer or something else with the pull up resistor inside. This made the harness more clean and easier to be done. On the other input, you can set pull up, pull down, more or less what you can do on the new version of the dash.
Perfect. And down here at the bottom, this is some terms that we tend to need to understand a little bit better. All inputs coming in. Talk about that last bullet point.
Yeah, every input used as digital, so on or off, could be monostable. Monostable is like a momentary function. When you switch the button, when you press the button, you have an on condition. When you remove your finger on the button, you return in the off condition. Bistable means that the input has two states. You press once the button and you remove your finger, and the input goes to on. When you repress the button, the input goes to off. So you can switch on and off without keep your finger pushed on the switch. Multistable is more or less the bistable with the multi-state. So when you push once, you have, for example, the value associated 1, 2, 3, 4, 5, and the end you can set to 0 to close the circle.
Perfect. Yeah. Configuration of inputs. This is just a little bit more information about some of the stuff that you just talked about, right? Maybe people can look at that a little bit deeper.
It's only a easy slide to understand the function. Analog, you have anything inside. You check the voltage. Analog with pull up 2 kilo ohm, useful to connect a PTC or NTC or something else without put a pull up on the cable. Digital with pull up and pull down. So in the same way, you don't need to put a pull up or pull down externally to the device. You simply put the switch and close to ground and close the button.
Perfect.
Very simple.
Perfect. Special inputs.
Yeah, PDM has also 3 special input. One of these is IGN, is the ignition. It's not programmable by user. It's only active IG because we have a pull down hardwired internally. And when activated, simply connect to the battery, switch on the PDM. So all the function related to the ignition will switch on into PDM. For example, the TFT and something else. We have also 2 different outputs that that are 11 and 12 that can switch on the PDM without give the functionality of the ignition. For example, we can connect a hazard push button to the channel 11 and 12, When we put 12 volt in this input, the PDM recognizes that has to be switched on. Check the ignition. Ignition is low, so all the function connected to the ignition, TFT, pump, all other outputs will remain in off condition, and only the output that is configured by this the input switch on. Best example is the hazard function.
Oh, okay. More than just a PDM, right? Is that additional features, right? There you go.
Yes.
LEDs, they're everywhere. There's 34 of them, it says.
Yeah, we have 34 status LEDs. It's very, very useful during the connection, during the test. Every output has a dedicated LED. Green means the output is enabled and it's okay. Red, there are some sort of alarm. Could be a short circuit, an open load, an overcurrent, or something else. Naturally, when the LED is off, means that the output is not active. We have also 2 additional LEDs that is related to the PDM. On, that is green when the PDM is active, and the other LED, that is status, that can inform the user about some behavior around the PDM. For example, if the battery is going low, LED switch on in yellow from 9 to 11, or if we have an over voltage related to the alternator malfunction, something else. If the temperature is going high, the LED switch on in yellow, and if the temperature goes higher than 85 degrees, the LED became red. Also, when the voltage goes very, very far from the optimal value, in this case over 16 volt and between 8 and 9 volt, the LED is red. Additional function is related to the very, very low voltage. If the voltage goes under 8 volt, we can have a minimal function typically on the load. So we blink, we made the red LED blinking, and we disable the outputs to avoid any type of malfunction.
And this is all interesting because you can, we're of course recording a lot of these things, but when you've got your race car and you don't have your computer connected, you can just look at the PDM and get good solid information about it. So
yes, you're right.
Perfect. Protection diodes inside the PDM.
Yes, this is a very, very difficult argument to touch. Protection diodes in the PDM are useful to reduce the inductive effect load. When earlier I speak about inductive load, I say that when we switch off the loads, the load itself generates a very, very negative spike of voltage. In this slide, we show what's happened with and without a freewheeling diode. The output is on the blue scheme in the app. At a certain point, we switch off the load. The voltage across the output pin goes to minus VF. Minus VF could be minus 400, minus 500 volt. This is the red line.
Oh, the red line, I'm sorry.
When we have a freewheeling diode inside, what's happened? The diode clamp the voltage to a very low level. We are speaking about 1 or 2 volts, and protect the output status of the power module. This means that big relay, solenoid valves, starter solenoid, big fans could be connected without any other diode externally, because internally we can manage also this very, very hard condition. Keep in mind that also L&M outputs has this feature inside, but is limited to 50 volts. That it means if you have to connect some loads that I described before, the best way is to connect to HB outputs or H outputs.
Okay. And this is just another example of where you might use that, right?
Yes, this is why we put a series diode on one output. Why only one output? Because it's very, very strange loads, the starter, and every car typically has only one starter. I mean, so we have a series diode on each one, and this is very, very useful to disconnect the outputs, the loads that typically auto-polarize itself. For example, the starter solenoid is a good example. We can go through the list to understand in detail what's happened. We activate the output H1. Current start flow from the PDM to the pole 1 of the starter. We have an internally little relay that switch with this current the pole 2 and the pole 4 together to put the battery to the main solenoid. That is the very high level of current. When we stop the H1, what's happened? The P4 and P2 are connected together. So we have a short circuit between the P4 and P1, that is our output. If H1 don't have an internal series diode, this current flows through the PDM to the main battery. And we have mainly two not good things. The first one is that we put the current into the PDM output, but this can be managed by the PDM. Is not a big problem. The big problem is that the starter motor remain engaged, and when the engine starts on, we have a big crash of the starter motor itself. So it's very important to use the H1 to start directly starter solenoid.
Perfect. There's a question from Brian that I do not know. Can we use the PDM to control a linear actuator speed and position? You drive an external device based on pressures or speed inputs, things like that.
Yeah, sure. Every input could be used as a condition to activate or deactivate or manage a different way, for example, for the PDM, for the outputs. So you can set a linear corrector or a potentiometer to manage what you do with the output. It's not a problem.
And that's where the pulse width modulation that you could give it different outputs, right? Not just a straight 12 volt or something.
One example of this is, for example, a water pump. We can connect a PWM output to a water pump and check the temperature of the water, and we can set the PWM level respect to the temperature of the water. When the water goes high, we can increase the PWM, so we can make the pump works in high speed way. When the temperature goes down, we can reduce the speed of the water pump.
Matt Romanowski wants it to do his active suspension on his race car, his personal race car. That might be a little bit much, right, Matt? But maybe a movable rear wing when you hit the brakes, right? Maybe something like that. So we are close on. We're up against it on time, but there's just a couple more slides left to go. So if you're able to hang around, everybody, I'd appreciate it. I do want to finish this and get all this information out. So we are going to continue to run just a little bit longer. So I appreciate it. Geez, and with that, I thought there was one more slide. Tell you the truth, I'm sorry. What I would like to do, and there are a couple more questions in the chat box we might want to do, but one thing I do want to do is have a second poll here real quick, as in case anybody puts another question in. You've now gotten a little bit of an idea of the AiM PDM. We've introduced it a little bit. You've seen some of the ideas and some of the different ways we can configure different things. I'd like to have a second poll that talks about this. How many, regarding the PDM outputs, being able to send information out, what possible send power out, what possible changes would you like to see in a typical installation? We've just talked about the PDM 32, so far today. The top choice one here is 32 mixed outputs, just like the current PDM 32 that we've been chatting about all today. What, from what you've heard, and maybe you've read some other things, or some of you have been thinking about getting one, would you like more outputs with less current, or would you like less outputs with more current, right? What kind of fits your car? Just, you may not even know the answers to this right now, which is fine, or more low side outputs, or more half bridge outputs. We'll leave that panel kind of going for just a moment to that poll, and let's see, let you think about it a little bit. You only have one, it's a single choice output. So any other questions that you might have seen go by, Fabrizio? What one of the questions that just popped up is the PDM 08, its little brother, the PDM 32's little brother, relatively close behind the PDM 32 on release. So when should these folks start to see
Yeah,
a little bit more of the 08s?
I think we are very near to close also that project. More of the function and more of the device is kept from the 32. So the developer as let me say more reliable for us, but we have the same conditions, so we use the same attention.
Yeah.
We put also the same circuit. So what we do for the 32 is more or less moved on the 8.
Perfect. Perfect. We talked a little bit about earlier about the two different screens that would be available, the 10-inch and the 6-inch. There's a picture of it there on our screen right now. Some of you might have wanted to see that. And I know Robbie, the link master, was putting links up there, and I think he put a spec sheet and some other things up for the different dashes as well. So I'm going to go ahead and close that poll and kind of start. I want to share the results so everybody can see those. And then we'll kind of close this out. Regarding those PDM outputs, what possible changes would you like to see? 86% of you thought that, at least from what you know right now, and I know it's fairly young here, but the PDM 32 is probably the right mixture, which is good to hear. There was about 10% that would like more outputs with less current. They want to drive more things, but not with not quite the large power needs. So, and then the last one was 3% said less outputs with more current. So give you an idea, some things that our guys can look at and study what your feedback is, and when we finish this up. So pretty good. The last question before we kind of close this out. Thank you. Also, can the V3 formula wheel be used with the PDM 08? And we talked about the V4 earlier. The one that's out there, that the V3 formula wheel, will it be able to use with the PDM?
Yeah, I think yeah.
Okay. Perfect. Is there Wi-Fi output for download from the track session from the PDM data logger side of this? Is Wi-Fi going to be available to everybody?
On the PDM is not available the Wi-Fi, only for a reason, because the chassis is, for obvious reasons, completely in aluminum, and the Wi-Fi don't like the metal around him. So we have the USB connector to put all information in and out from the PDM.
Interesting. Okay. Perfect. I appreciate that. To kind of start to close this out, we're just a few minutes over, which is kind of typical for me, but and I try really hard to not go too long on you guys most of the time, but we start talking about stuff we love, right? But this video, as well as all the rest of them, are placed up on our YouTube site within an hour or so, if at all possible. And this one will be the same. We'll put all the links that we talked about today. Those will all be out there. This will make number 117 videos, including all of these 51 webinars that we've done so far. So look forward to going out and taking a look at this. I know we went through a lot very quickly, and you may want to go back out and review some of this, and so it'll be out there for you shortly. The customer support, gosh, we're out there all the time. I know we're all traveling a ton. I've even got to go out to a few events, and maybe this coming weekend as well. So look for us out at the track. Look forward to seeing you all there. If you don't see us at the track with our vans or our backpacks, there's your 800 number. Give us a call. We're a customer support company that happens to sell racing electronics, and so we'd just love to help you and get you up to speed, get you going. So give us a holler. The next webinar. This is something that I mentioned earlier in this webinar. We occasionally take a poll towards the end of the event and end of these webinars, and we ask you, hey, we give you 8 or 10 choices. The last one that I did, we did the topic that won last time was Race Studio 2 tips and tricks in analysis, and we did that webinar. And then the right behind it was suspension analysis, which we did about 2-3 weeks ago. And the third place one of those was engine RPM analysis. And so I thought about doing another poll today, and I thought, you know what, people have voted already. Let's just take the next in line. We'll probably do another poll here shortly. So So on Thursday, this coming Thursday, we're gonna dive into the engine RPM analysis function. We're gonna talk about its strengths and its weaknesses, and maybe a number of tips and tricks on how to make it work for you, and where you kind of can hang your hat on looking at differences and where you shouldn't. Right? We are calculating something from on-track data, so we got to be a little bit. We need to understand what we're looking at and understand the positives of those values that we get back. So we'll talk all about that on Thursday. I'm going to go ahead and host that. Maybe I'll suck somebody in to help me or something. We'll see, but no big deal. So we'll be doing that on Thursday. So I look forward to that. So to kind of close this out, Fabrizio, I appreciate it. I know it's a ton of work to do these, to get prepared to do these. This is just number one of several. We're hoping to do maybe 3, maybe 4, and maybe 3 weeks apart, something like that, where we could just continue to add and build on what we've just talked about today. So today was just the introduction, and there was lots of questions that I seen fly by that were better suited for us to dig into in detail in future webinars about the PDM. So looking forward to that. Again, I appreciate it. Is there anything else you'd like to add on as we're kind of closing this one out, Fabrizio?
Yeah, I want to thank you and AiM for the opportunity, and I think we can do a great job with this new device. We have to explain better and deeper in the next webinar, but I think we can do it very, very well.
It is a very complex device, and so we're going to be doing a lot of this as best we can, because it's not something you're just going to bolt into your car and in a couple of nights have it up and running for next weekend. That's not the way this works. So there's a lot of technical information that we need to make sure everybody understands and to get the most out of this. So we're going to continue to do these. We'll do these like every 3 weeks or so. We'll do 3, 4, whatever, and we'll have the videos out there available for people to look at, and as they're learning about these tools. So again, I appreciate that. I appreciate all of our guys out on the AiM guys in the background. They've been answering questions like crazy, and working with you in the chat box. I appreciate all of you guys. Look forward to seeing you in a couple of days on Thursday to talk about the engine RPM analysis. Thank you again, Fabrizio. Thanks everybody. Thanks all of you guys for coming and watching. And we'll see you on number 52 here in a couple of days. Talk to you soon.
Bye-bye.